Hi, my name is Diego Porres, my advisor is Antonio Lopez, and the title of my thesis is Visual Domain Adaptation from Virtual to Real World. So first, as an overview of my previous and current work, I worked in image compression, where we basically saw how to use a GAN as a part of a pipeline for a lossy image compression. And we are currently working on visual domain adaptation for end-to-end driving, which is using synthetic data to train an end-to-end model. But of course, this comes at a cost since there's a domain gap between these two. So this is the overview of the image compression model, where we have an image, we project the latent space, then we transmit this latent vector, and we can just store it along with the generator, and we can recreate the image. But if you see there's issues with this, it's not recreated perfectly. It might delete some objects, but which are important for the car. At the end of the day, it both took too long to project, as well as it might remove some objects that are important for the car. So it was too dangerous, so we didn't continue with it. We do note, however, the capabilities of the Stylegram 2 model to generate neon scene images, like here, where we take two source images and we do style mixing between them, and we can see that we can generate neon scene images, or basically with different weather than the original ones. So currently we're looking into visual domain adaptation for end-to-end driving, and the idea is to train an end-to-end autonomous driving model, such as specifically conditional imitation learning with synthetic data, and deploy it to the real life. And of course, this won't work unless we do modify the training data, because the synthetic data doesn't look at all like real life. So we'll use several image-to-image translation techniques such as cyclogram, M-unit, and F-unit, possibly others in the future. So as a first step, we'll train the model in Carla using low-quality settings and then we'll want to translate this model into Carla with epic quality settings. So basically, in this first step, low quality will act as our virtual world, and epic quality will be our real world. And you can see the differences of both. So some preliminary results, Cyclodan can handle pretty well the translation from low to epic and vice versa, especially since it doesn't delete objects. But it assumes that the interdomain mapping is one-to-one, which is not always the case with the street scene because of the changing weathers. Some results are seen here of translating from town 1 to town 2. To solve this, we look into M-unit, which is multimodal unsupervised image-to-image translation. One scene in load or epic domain can have different translations from into the other. Like for example, this one, load, can have multiple equal scenes in epic setting. So some artifacts are appearing still on this translation, so we have to do a better selection of the hyperparameters. To address the future problem of the fact that real data is scarce, we test F-unit, which is F4 few shot, which is much more prone to artifacts, like we can see on these 4 examples here, translating from different weather types or different quality settings. Either some artifacts appear or the vehicles are disappearing, so we have to be careful with this. However, this is powerful since we can use, for example, 5 images of the A2D2 dataset to translate this image into this equivalent into the A2D2. The domain gap between A2D2 and low quality perhaps is too large, since it doesn't know what's translated. So as future work, we are concluding on which of these things to use. We will then have some baselines, train a conditional intuition learning model on both low only and only epic quality settings. Then we see how a conditional intuition learning model trained with low to epic images goes, and eventually translate this into the 1/8 model car. But where in real life should we test it? And this is part of some of the personal challenges, which is We don't want to delete or replace objects in the road that are important. And is even having a good translation important for the car. Training deep learning models, especially GANs, is still hard, so I should keep practicing doing this, as well as continue brushing my software engineering skills. And last but not least, learn how to work from home. Thank you.